is an AI first design assistant showcasing how Electrolyzer Scheduling Advisor Copilot is built using Microsoft Plan Design. This solution demonstrates how AI solutions supports hydrogen production planning by intelligently scheduling electrolyzer operations based on renewable availability, energy cost, and equipment constraint. Electrolyzer Scheduling Advisor follows an AI first design approach. Instead of static schedules or manually adjustments, intelligence is embedded directly into the planning workflow. Copilot continuously evaluates the input and recommends when to run, pause, or adjust productions, making hydrogen planning, availability, and energy saving and equipment related constraints. This electrolyzer scheduling advisor follows an AI first design approach. And as a first step, this solution begins with a clear definition of hydrogen production and operation requirements. These requirements are entered into the plant designer, which generates a structured plan outlining process, system components, and operational rules. The plan serves as an architectural backbone, ensuring AI, automation, and production planning work together seamlessly. These are the user roles: production planner, operation technician, maintenance engineer. This is good. So we'll go ahead and create the process outline first. Now, my plan design is going to suggest me all the processes that can be created for this requirement. Let's go over one by one and finalize if this is looking good or not. The first process that has been outlined here is input capture and forecast review. This process involves gathering and validating all necessary inputs for AI driven scheduling, including renewable energy forecast, indicative energy cost, and equipment maintenance constraints. It ensures that AI has accurate, up to date data to generate optimal schedules. Let's look into the process. What does this does? Renewable generation forecast, indicative energy cost, and electrolyzer constraints are captured and prepared for AI analysis. So we are gathering all the required input here. Sent it to the production planner is input for the renewable energy forecast. The input is done by maintenance engineer. Maintenance engineer required equipments, operating equipment. Once the input is fed, system validates it, makes decision, and then capture and forecast the review. Let's see the other process. The second process is AI schedule optimization and recommendation. The AI analyzes input data to generate optimized hydrogen production schedules, balancing cost, renewable availability, and asset health. It provides explainable recommendations, scenarios, comparison, and highlight trade offs to support the plan decision making. Let's see how this process works. Copilot evaluates multiple operating scenarios, balancing cost, efficiency, renewable utilization, and equipment health. So, first, it gathers the input to generate optimization, generates alternate scheduling scenarios, system produces explainable rationale and highlights, production planner reviews AI optimized schedules, The planner compares alternative scheduling, and the planner understands the rationale and trade off behind it. So, this process is also looking good to me. The third process that has been outlined here is approval and, approval and execution workflow. This process covers the review, approval, and assignment of selected production schedule to operations. It includes communicating clear instructions to the technicians, acknowledging task execution, and collecting operational feedback for continuous improvement. So the production planner reviews and approves the production, makes the decision, and creates the system creates and communicates clear task instructions. Operates operations technicians acknowledge the report, technician provide feedback, and system collects the feedback from them. And the next is monitoring and continuous learning. This process involves tracking actual production versus the AI generated schedule, monitoring performance, and feedback feeding back the results into the system so that it can do the further learning. Let's see how the process works. Actual production outcome are monitored and compared against planned schedules. This results continuously improve Copilot future recommendation. System compares actual production to AI generated, monitors performance metrics and identifies the backlogs. Analysis cause of deviation and performance issue. System updates AI scheduling model to improve further. System monitors maintain events and adjusts schedule. Production planner reviews monitoring insight and does continuous learning. So these are the processes that are suggested and it looks good to me. So I will confirm that one. Once I confirm the process, my data model is getting created. As you can see, the table that are suggested are electrolyzer, renewable forecast, energy cost forecast, operating constraint, production schedule, schedule recommendation, schedule scenario, schedule task, feedback, maintenance requirement, user. Yeah, this is okay for me. And then my technological stack is being suggested. I can create an agent for the advisor. I can create workflows for approval handoff. I can create an app, maintaining plugging suite, and then a report can be generated. All of this looks good, so I'll just confirm. My tables are getting saved. Once the tables are created, I'll be able to create it by hovering over the respective app or tool that I want to create. By clicking on the plus sign, I'll be able to create it. Yeah. So now if you see, I have this agent. Let me go and click on the create. The creation happens in the next page. Similarly, I can create all these tools. So this is how Electrolyzer Scheduling Advisor, designed using AI first, enables smarter hydrogen production operation become more effective, cost efficient, and reduced dealer copilot design and how the apps are created, the data models. Now I will show you the output, how the app and agent looks like. So I'm currently in the operator schedule companion app. So this is a Canvas app. It has three different schemes. One is schedule tasks, schedule recommendations, and schedule feedbacks. Let me go inside and show you how it looks like. You can create new or edit the existing one. This is my schedule recommendation data. I also have schedule feedbacks. This is the dashboard. So this is one app which we have created for this solution. Next, we have also created an agent for the same purpose. And I have run a couple of test cases here, which I will walk you through. Now, as you can see, I'm asking for a production schedule. It has given me the schedule, if it has executed, approved, cancelled with the status and the timelines and everything. Next, I'm asking for a schedule up to date information. So it gives the electrolyzer, the schedule date, and the status if it is proposed or cancelled, and it is being grounded with the data. So this is how the agent and apps looks like for the scheduling advisor.